Right now, an interstellar visitor is passing behind our sun, hidden from every telescope on Earth during what should be its most revealing moment. For months, the world's most powerful space agencies promised us clarity about this object. Instead, they delivered fuzzy dots and sudden silence. The timing of their blackout is either the worst coincidence in astronomical history or the most carefully orchestrated information vacuum ever created. Why would 7 Mars orbiters, positioned for the shot of a lifetime, simultaneously fail to show us what they actually saw? Consider the improbability of this moment. In the vast darkness between stars, where the average distance between stellar systems spans trillions of kilometers, something left its home, whether by natural ejection or deliberate launch, and traveled for what could be millions of years to arrive here. Now, in October 2025, during the brief window when humanity possesses the technology to detect such objects, but still lacks the capability to visit them directly. The universe is approximately 13.8 billion years old. Earth has existed for 4.5 billion years. Modern humans have walked this planet for perhaps 300,000 years. We've had radio telescopes for less than a century. And in this infinitesimally small slice of cosmic time, an interstellar object arrives on a trajectory that points back to where an unexplained radio signal originated 48 years ago. Coincidence? Perhaps. The universe is under no obligation to make sense to us, to arrange itself according to our expectations of probability and meaning. Tonight, we're going to explore what happened when 3I Atlas, only the third confirmed interstellar object ever detected, made its closest approach to Mars in October of 2025. We'll examine the disappointing images that enraged the astronomy community, the high-resolution photographs that should exist but remain mysteriously unreleased, and the amateur observations that somehow revealed more than billions of dollars in professional equipment. We'll calculate the statistical probability of this object's trajectory and arrival angle so unlikely it occurs in less than 1% of all possible approaches. We'll investigate the connection to a 48-year-old radio signal that may have announced this visitor's approach decades before we knew it was coming. And we'll document the social media suppression campaign that began the exact moment these questions grew too loud to ignore. But beyond the technical details and statistical anomalies, we'll explore something more fundamental: what this moment reveals about humanity itself. How we react to uncertainty. How we balance skepticism with wonder. How we navigate the space between what we hope to find and what we fear discovering. The stakes are extraordinary. Within weeks, 3I Atlas will emerge from behind the sun. What it does next, whether it continues passively outward on its hyperbolic trajectory or demonstrates technological capability, could fundamentally alter humanity's understanding of our cosmic neighborhood and our place within it. Every comet that passes through our solar system carries within it the frozen chemistry of another stellar neighborhood, a snapshot of conditions around stars we'll never visit. Every interstellar visitor is a messenger from regions of space, impossibly distant, bearing information about planetary formation, stellar evolution, the diversity of cosmic environments. But 3I Atlas carries something: additional questions that won't stay quiet, anomalies that accumulate rather than resolve, patterns that suggest either extraordinary coincidence or deliberate design. If you're as fascinated by this unfolding mystery as I am, I encourage you to stay with me for the next 2 hours. We'll walk the line between rigorous science and open-minded speculation, always distinguishing between what we know and what we wonder. We'll examine evidence, calculate probabilities, explore hypotheses ranging from mundane to extraordinary. So settle in, turn down the lights, let the day's concerns fade into the background. And let's explore what might be the most important cosmic visitor to enter our solar system in recorded history. The universe waits patiently, as it always has, for us to ask the right questions. October 7th and 8th, 2025 will be remembered as the moment the space community collectively lost its patience. For months, we'd been building toward this. 3I Atlas. Only the third confirmed interstellar object ever detected passing through our solar system was making its closest approach to Mars. 7 different spacecraft from 4 space agencies were positioned to capture unprecedented images. The hype was real. Scientists promised us clarity answers, maybe even proof of what this thing actually is. Think about the choreography required for this observation. Mars orbits the Sun at an average distance of 228 million kilometers, taking 687 Earth days to complete one orbit. It doesn't sit still. It's constantly moving at about 24 kilometers per second faster than anything humans have ever built. Coordinating multiple spacecraft each with their own orbital mechanics, their own power constraints, their own communication schedules with Earth, to all point their cameras at a single fast-moving target. Millions of kilometers away represents a triumph of orbital mechanics and international cooperation. The timing window was narrow. 3I Atlas was approaching at 67 kilometers per second relative to the Sun. At closest approach to Mars on October 3rd, it would be just 30 million kilometers from the red planet, close in cosmic terms, though still about 78 times the distance from Earth to our moon. The object would be visible for only a brief period before geometry carried it past Mars and deeper into the inner solar system. Mission planners had months to prepare. Imaging sequences were designed, exposure times calculated, tracking routines programmed. Each spacecraft would contribute unique data, different wavelengths, different resolutions, different angles of observation. Combined, they would create a comprehensive portrait of this visitor from beyond our solar system. And then the images dropped. The European Space Agency's ExoMars Trace Gas Orbiter, positioned just 30 million kilometers from 3I Atlas during its closest approach on October 3rd, released a series of images that can only be described as profoundly underwhelming. A fuzzy white dot moving slowly across a star field. No detail, no structure, nothing that would help us understand whether we're looking at a natural comet or something far stranger. The images looked like something you might capture with a cheap webcam pointed at the night sky, grainy, indistinct, devoid of useful information. After months of anticipation, after the coordinated effort of multiple space agencies, after the millions of dollars and euros and yuan spent positioning these sophisticated instruments, we got this. The backlash was immediate and savage. Astronomy Vibes, a popular space commentary account on X, posted a side-by-side comparison that went viral within hours. On one side, a crisp, detailed image of Comet Lemon captured by an amateur astrophotographer with a simple mirrorless camera. On the other side, the ESA's image of 3I Atlas. The caption read, "If a simple mirrorless camera can catch Comet Lemon, why can't NASA capture 3I Atlas passing close to Mars?" The post, currently, has over 40,000 reposts and counting. But it was the follow-up that really struck a nerve. Billions in funding, and this is the best photo they've got. Looks more like a weather balloon in a foggy backyard. The comment sections erupted, thousands of people expressing frustration, disbelief, anger. Some questioned the competence of the space agencies. Others suggested deliberate obfuscation. Many simply expressed profound disappointment that after all the buildup, we learned essentially nothing new.
To understand why people are so angry, you need to understand what we were expecting versus what we got. The Cassis camera aboard the ExoMars Trace Gas Orbiter has an angular resolution of 11.36 microradians per pixel. At 30 million kilometers, the distance between the spacecraft and 3I Atlas during closest approach, that translates to approximately 340 kilometers per pixel. Let that sink in for a moment. 340 kilometers per pixel. For context, that's roughly the distance from Boston to Washington, D.C. Imagine trying to photograph a house in Philadelphia from Boston, but your camera's resolution is so poor that each pixel captures an area spanning from New York to Baltimore. You wouldn't see the house. You wouldn't even see the city. You'd see a vague blur representing the entire mid-Atlantic region.
For further context, the estimated nucleus of 3I Atlas is somewhere between 5 and 46 kilometers across, based on brightness measurements and assumptions about its reflectivity assumptions that could be completely wrong if the object's surface has unusual properties. That means the entire solid core of this object, the actual comet nucleus itself, would occupy at best a fraction of a single pixel in these images. You're not looking at a photograph of 3I Atlas. You're looking at the diffuse glow of its coma, the cloud of gas and dust surrounding the nucleus smeared across a handful of pixels. It's like trying to photograph a person by capturing the shadow they cast from a kilometer away. You get a shape, but no detail, no features, nothing that tells you anything useful. But here's where it gets interesting. The ESA knew this going in. They knew their cameras were designed to photograph the bright Martian surface from just a few hundred kilometers away, not faint objects tens of millions of kilometers distant. Nick Thomas, the principal investigator for the CAS's camera, admitted as much in the official statement. This was a very challenging observation for the instrument. The comet is around 10,000 to 100,000 times fainter than our usual target. So why release images they knew would be inadequate? Why build up expectations for months only to deliver something that provides zero new information? The official story is that they released what they had, that these represent the best possible images from the equipment available. It's a reasonable explanation. Scientists are excited about their observations. They want to share with the public. They want to demonstrate that their spacecraft performed as expected during this rare opportunity. But the timing feels deliberate, almost like a pressure release valve. Give people something, anything to look at while the real data stays locked away. Because make no mistake, there are better images. Much better images. And they're being held back. While the ESA was releasing fuzzy dots, NASA's Mars Reconnaissance Orbiter was capturing something entirely different. The HiRISE camera, short for High Resolution Imaging Science Experiment, is the most powerful camera ever sent to another planet. Its resolution is so precise that from Mars' orbit it can distinguish objects the size of a kitchen table on the Martian surface. When pointed at distant celestial objects, this same instrument becomes an extraordinarily capable deep space telescope. When 3I Atlas made its closest approach to Mars on October 3rd, HiRISE had a resolution of approximately 30 kilometers per pixel at the distance of the object. That's more than 10 times better than what the ESA cameras achieved. If there's any structure, any unusual features, anything that doesn't fit the natural comet narrative, HiRISE would have seen it. Avi Loeb, the Harvard physicist who's been tracking 3I Atlas since its discovery, put it bluntly in his latest blog post. The brightest pixel in the HiRISE image will provide the best constraint yet on the area of 3I Atlas. We are all hoping that the HiRISE team will release their images as soon as possible. That was written on October 7th. It's now weeks later, still nothing. The official explanation is the United States government shutdown. Over 15,000 NASA employees, more than 80% of the agency's workforce, have been furloughed. The agency's website isn't being updated. Public communications have ceased. It's bureaucratic paralysis at the worst possible moment. On the surface, this makes perfect sense. Government shutdowns happen. They disrupt operations. They delay releases of scientific data.
It's frustrating but understandable. But here's what doesn't add up. The ESA released their images. They're a European agency completely unaffected by American political dysfunction. China's Tianwen-1 orbiter was also positioned to observe 3I Atlas with its moderate resolution imaging camera. Also silent. The UAE's Hope orbiter, equipped with the Emirates Exploration Imager, had a clear shot as well. Nothing. Multiple space agencies.
Multiple sovereign governments with completely separate bureaucracies and priorities, all simultaneously unable or unwilling to release their best data on the most scientifically significant object to visit our solar system in years. The pattern is hard to ignore. Social media is ablaze with speculation. Some say coordination that back-channel communications between space agencies have resulted in an agreement to withhold data pending some kind of comprehensive analysis or review. Others suggest something was seen that requires careful contextualization before a public release, something that might be misinterpreted or cause unwarranted panic if released without proper framing. The more conspiracy-minded suggest the images show something so anomalous that releasing them without extensive preparation would trigger mass panic, economic disruption, or social instability. That last theory sounds absurd until you remember what's been happening over the past week with amateur observations. Because while the professional space agencies have been coy with their data backyard, astronomers have been capturing images that raise more questions than they answer. On October 3rd, the exact day 3I Atlas made its closest approach to Mars, a Portuguese amateur astronomer operating under the username Dobsonian Power uploaded an image that immediately went viral. Using nothing more than a solar telescope from his backyard and some aggressive digital enhancement, he captured what appears to be angular structure within 3I Atlas. Dark geometric shapes, protrusions that don't match the typical diffuse glow of a comet's coma. The caption he added was simple but loaded with implication. What on earth is it? Within 6 hours, the image had been shared across every major astronomy forum subreddit and social media platform. The reaction split into two camps almost instantly. One group saw clear evidence of artificial structures, proof that 3I Atlas is not what mainstream science claims it to be. The shapes looked too regular, too geometric, too deliberate to be natural formations. Forums filled with excited speculation about solar panels, antenna arrays, hull plating. Some claimed to see symmetry that shouldn't exist in a random chunk of ice and rock tumbling through space. The other group dismissed it as classic pareidolia, the human tendency to see patterns where none exist, amplified by processing artifacts from inappropriate equipment. They pointed out that you can see faces in clouds, animals in wood-grain conspiracies in random noise. The brain is a pattern-seeking machine evolved to detect predators in shadows and food sources in foliage. That same machinery applied to ambiguous visual data generates false positives constantly. The debunkers had solid technical arguments. Solar telescopes use specialized filters designed for observing the sun's extreme brightness, not faint deep space objects traveling at interstellar velocities. The equipment simply wasn't built for this kind of observation. These filters block most wavelengths of light except for a narrow band, typically around the hydrogen alpha line at 656.3 nanometers. This allows astronomers to study solar prominences and surface details without being overwhelmed by the sun's overall brightness. The sun, remember, is blindingly luminous, about 400,000 times brighter than the full moon as seen from Earth. To observe its surface features, you need to filter out the majority of that light, or you'll damage both your equipment and, potentially, your eyesight. Solar filters are incredibly specialized tools, optimized for one specific purpose, making our star dim enough to study safely. But when you point that same equipment at a comet, an object that's already extremely faint and whose light is reflected sunlight containing all wavelengths, you're essentially throwing away most of the available photons and trying to image with whatever happens to pass through your narrow filter. Imagine trying to identify someone in a dark room while wearing sunglasses specifically designed to block 99.999% of incoming light. You might see something, but you certainly can't trust the details of what you think you're seeing. Add aggressive digital enhancement to compensate for the inadequate setup, and you're essentially asking an algorithm to invent details that aren't really there. Modern image processing software, especially AI-powered tools, are remarkably good at filling in missing information based on assumptions about what should be there. But should is the operative word. The algorithm doesn't know what's real. It only knows patterns it's been trained on. It's the astronomical equivalent of enhancing a blurry photo until you start seeing faces in the noise. Law enforcement learned this lesson decades ago, when enhanced images led to false identifications and wrongful convictions. The computer can make an image look clearer, but that doesn't mean it's showing you what was actually there. Any image processing expert will tell you garbage in, garbage out. But here's where the story gets complicated. Dobsonian Power isn't some random internet conspiracy theorist with a cheap telescope and too much imagination. He's a respected amateur astronomer who's been sharing legitimate astrophotography work for over a decade. His YouTube channel features careful documentation of his equipment, his methods, his image processing workflows. He shares his raw data. He discusses his techniques openly. He invites critique from other amateur astronomers. This isn't someone trying to manufacture evidence for clicks. This is someone with a genuine interest in observational astronomy who captured something unusual with equipment that admittedly wasn't ideal for the task. And when pressed on the anomalous structures in his 3-eye atlas image, he didn't double down with wild claims. He didn't start selling books about alien spacecraft or launch a crowdfunding campaign to build a better telescope to reveal the truth. Instead, he acknowledged uncertainty.
He admitted the limitations of his equipment. He engaged thoughtfully with critics who pointed out the technical problems with using solar equipment for deep space imaging. He promised to try again when the object becomes visible from Earth in early November, after passing behind the sun, hopefully with more appropriate equipment. He invited other amateur astronomers to image the object and compare results. His response was measured scientific, appropriately cautious, which makes the reaction to his image even more telling. Within 24 hours, multiple websites published articles specifically debunking his capture. Amateur telescope captures strange atlas image. Here's why it's not what it seems. The timing felt coordinated. The tone felt defensive, as if someone needed to quickly establish the narrative that nothing unusual had been photographed, that any apparent anomalies were merely technical artifacts before the image could gain too much traction.
The articles weren't just explaining the technical limitations of solar telescopes for cometary observation, a reasonable educational goal. They were dismissive, almost mocking, in places treating the observation as obviously false rather than simply ambiguous. There was an urgency to the debunking that felt disproportionate to the claim being made. And then the enhancement wars began. Users across Reddit, Twitter, and various conspiracy forums started downloading the original ESA images and running them through their own processing algorithms. Some used standard astronomical image stacking techniques. Others employed AI upscaling tools designed for enhancing low-resolution photos. A few went full chaos mode with machine learning models trained to reconstruct fine details from limited data. The results varied wildly. Some showed nothing but slightly sharper versions of the same fuzzy dot. Others revealed what appeared to be distinct geometric patterns, edges, structures that seemed too regular to be natural ice and rock. One particularly viral version showed what looked like a hexagonal array of bright spots, like windows on a spacecraft or solar panels catching sunlight. The problem is that once you start aggressively processing an image, especially with AI tools, you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train an AI on thousands of images of spacecraft and then ask it to enhance a blurry dot, it might very well invent spacecraft-like details because that's what it's learned to recognize. It's pattern completion, not discovery. It's a scientific dead end wrapped in the illusion of clarity. But the proliferation of these enhanced images had an unintended effect. They muddied the water so thoroughly that distinguishing between legitimate amateur observations and outright fabrications became nearly impossible. Within 48 hours of the ESA photo release, there were dozens of supposedly enhanced versions circulating online. Some showed metallic surfaces. Others depicted what looked like solar panels or antennae arrays. A few even included running lights and visible thrusters complete with glowing engines. Most were obviously fake digital art created by people with too much time and too much Photoshop skill having fun with the speculation or deliberately trying to muddy the waters. But mixed in with the noise were a handful of images that felt different, more subtle, less sensational. Images that showed just enough unusual regularity to make you wonder whether something real was being obscured by the flood of obvious hoaxes. It's a classic disinformation tactic actually, whether deliberate or emergent. Flood the zone with so much garbage that the signal gets lost in the noise. Make it impossible for casual observers to distinguish between legitimate anomalies and manufactured nonsense. And then just when the amateur imaging situation couldn't get more confused, something appeared on 4chan that changed the entire conversation. On October 4th, an anonymous user on 4chan's paranormal board posted what they claimed was insider information about 3i Atlas. The post was titled simply, ESA Data Leak, and it began with a credential claim that was specific enough to sound legitimate, but vague enough to maintain anonymity. I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3i Atlas. Internet leaks are a dime a dozen. Most are easily dismissed as creative fiction or outright trolling. The signal-to-noise ratio on 4chan is notoriously abysmal, but this one was different. The level of technical detail was unsettling. The poster didn't make wild claims about alien invasions or secret military operations. Instead, they laid out a series of specific observational anomalies that, if true, would fundamentally challenge our understanding of what 3i Atlas actually is. The first, anomaly chemical impossibility. According to the post-spectroscopic analysis shows, 3i Atlas is releasing approximately 100 kilograms of nickel gas per second, but with almost no iron emission. In normal stellar and planetary chemistry, nickel and iron are inseparable twins. They form together in supernova explosions. They travel together through interstellar space, and they appear together in comets and asteroids locked in ratios determined by nuclear physics. Finding abundant nickel with virtually no iron is like finding smoke without fire. It violates basic assumptions about how matter behaves in natural cosmic environments. Think of it this way: when a massive star dies in a supernova, the explosion creates heavy elements through rapid neutron capture, a process called the R process. Iron with 26 protons and nickel with 28 protons are produced in similar nuclear environments. Their abundance ratios are well understood and remarkably consistent across astronomical observations. Every meteorite we've analyzed, every stellar spectrum we've measured, every comet we've studied, the iron-to-nickel ratio falls within a predictable range. It's one of those cosmic constants you can count on. Except apparently with 3i Atlas. The second anomaly, thermal contradiction. The object is releasing massive amounts of gas and dust, the characteristic signature of an active comet being heated by the sun. But infrared observations show it remains cold, far colder than it should be given its outgassing rate and proximity to solar radiation. The poster compared it to watching someone sweat profusely in a freezer. The physics don't match the observation. When sunlight hits a comet, the energy is absorbed by the surface, causing ice to sublimate, to transition directly from solid to gas without becoming liquid. This is an endothermic process, meaning it absorbs heat. But the amount of heat required to produce the observed outgassing rate should still leave the nucleus warmer than what infrared measurements indicate. It's as if 3i Atlas is somehow absorbing solar energy and redirecting it without the expected thermal signature. That's not how normal thermodynamics works. The third anomaly, trajectory precision. The post referenced what Avi Loeb has been saying publicly, that 3i Atlas arrived with an orbital inclination of just 4.89 degrees relative to Earth's ecliptic plane. But the 4chan poster added something Loeb didn't emphasize: the trajectory isn't just unusual. It's a perfect straight shot from the direction of the galactic core. No wobble, no deviation. No signs of gravitational perturbation from nearby stars during its millions or billions of years traveling through interstellar space. As if it was aimed, objects traveling through the galaxy should show the effects of their journey. Random gravitational nudges from passing stars, slight course corrections from encounters with molecular clouds, the accumulated chaos of a long voyage through space. 3i Atlas shows none of this. Its trajectory, when traced backward, points to a specific origin with almost no scatter. Then came the part that elevated this from interesting speculation to something darker. The poster claimed the object fits the profile of what they called a post-biological entity, not a natural comet, not a conventional spacecraft, but something in between. They described it as having a 3-phase particle engine with an estimated power output of 75 megawatts, continuously transmitting an active signal and, in their words, probing our solar system. 75 megawatts. For reference, that's about the power output of a small power plant, concentrated into an object traveling at 67 kilometers per second relative to the sun. The post concluded with a theoretical framework that was either brilliantly creative science fiction or genuinely disturbing insider knowledge. The poster suggested 3i Atlas might be a macroscopic quantum object, specifically something called a Q-ball. It's an exotic theoretical construct from particle physics, a type of non-topological soliton that could theoretically exist at scales far larger than subatomic particles. In standard physics, quantum effects are confined to the microscopic realm: electrons, photons, individual atoms. But certain theories propose that under specific conditions, quantum coherence could be maintained across much larger objects. A Q-ball is one such possibility. It's a lump of matter held together not by chemical bonds or gravity, but by quantum field configurations. If stable, a Q-ball could have properties that seem impossible under normal physics. It could be incredibly dense while appearing diffuse. It could absorb and redistribute energy instantaneously across its entire structure, explaining the thermal contradictions. It could even explain the nickel without iron problem if the Q-ball's internal quantum state preferentially produces certain isotopes. This is deeply speculative physics, the kind of thing discussed in theoretical papers but never expected to exist in reality. And yet, here was someone claiming that an interstellar object currently passing through our solar system might be exactly such an entity. Within 18 hours, the post had been screenshot and shared across Reddit, Twitter, and dedicated UFO research forums. The conspiracy subreddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims. But locking the thread didn't stop the conversation. It just moved it to other platforms, fragmenting into dozens of parallel discussions, each pulling the original post in different directions. Some focused on the chemical anomalies, trying to find natural explanations or alternative interpretations of spectroscopic data. Others zeroed in on the Q-ball hypothesis, debating whether such objects could actually exist and what properties they would have. A few started connecting it to earlier claims about 3i Atlas potentially being the source of the 1977 WOW signal, and that connection to a 48-year-old mystery that has haunted astronomers for decades deserves its own examination. But before we dive into the WOW signal connection, there's another piece of this puzzle that emerged on October 4th and threw the space community into confusion. NASA's Perseverance rover, sitting in Jezero crater on the Martian surface, captured something in the night sky above. The image from its right navigation camera showed an elongated streak of light roughly 4 times longer than it was wide. At first glance, it looked like a typical long-exposure capture of a moving object. Comets and asteroids often appear smeared in images when the camera tracks stars instead of the object itself. Standard stuff, except the math didn't work out that way. When people started calculating the apparent size of the streak based on Perseverance's known camera specifications and the distance to 3I Atlas. At the time, they arrived at a disturbing number 50,000 kilometers long. That's not a comet nucleus. That's not even a comet with a tail. That's something else entirely. For comparison, Earth's diameter is less than 13,000 kilometers. If this streak represented the actual physical size of 3I Atlas, we were looking at an object nearly 4 times wider than our entire planet. Social media exploded with speculation. Was 3I Atlas actually a massive cylindrical craft? Had it been masking its true size and shape this whole time behind a diffuse cloud of gas and dust, like a cosmic smokescreen? The timing felt significant. This image emerged just 1 day after the Mars flyby, right when all the professional space agencies went mysteriously quiet. Some saw it as confirmation that something deeply anomalous had been photographed, something that couldn't be easily explained away. The speculation reached high enough that Representative Ana Paulina Luna, a member of Congress, known for her interest in unexplained aerial phenomena, reached out directly to Avi Loeb for his analysis. Think about that for a moment. A sitting member of the United States House of Representatives felt compelled to contact a Harvard physicist about a photograph from Mars. That's not normal protocol. That suggests someone in official channels was concerned enough to want expert interpretation outside the usual NASA communication pipeline. Loeb's response was thorough and on the surface reassuring. He calculated that the Perseverance nav cam has an angular resolution of 0.33 milliradians per pixel. At the distance of 3I Atlas, when the image was taken approximately 38 million kilometers, that translates to about 12,500 kilometers per pixel. The streak in the image spans roughly 4 pixels, which gives you that 50,000 kilometer length. But Loeb argued this was an artifact of composite imaging. The streak wasn't showing the actual size of 3I Atlas. It was showing the path the object traced across the Martian sky during a long integration time, likely around 10 minutes of stacked exposures. His reasoning was solid. Mars orbits the Sun at 24 kilometers per second. 3I Atlas was traveling at 67 kilometers per second relative to the Sun in the opposite direction. That gives it a relative velocity of over 90 kilometers per second compared to Mars. Over 10 minutes, that's exactly 54,000 kilometers of travel, perfectly matching the observed streak length. The shape wasn't the object. It was the object's motion smeared across time like a car's headlights in a long exposure photograph. Case closed, right? The cylinder theory debunked by basic physics and careful math. Except Loeb included one sentence in his analysis that conspiracy theorists latched onto like a lifeline. If the nav cam images represent single snapshots with an exposure time below 3.28 seconds, then the brightness and angular length of the observed source imply that it is not 3I Atlas. In that case, the source might be much closer to the camera, capable of being smeared into an elongated image with a smaller spatial size and a smaller speed. Wait, if these are single-frame captures, then what Perseverance photographed wasn't 3I Atlas at all. It was something else, something closer to Mars. That qualifier opened a door that no amount of subsequent clarification could fully close, because NASA hasn't confirmed whether the image is a composite or a single frame. They haven't released the metadata. They haven't provided the exposure time or the number of stacked images. The government shutdown excuse applies here too. No staff to process requests, no one available to confirm basic technical details about how the image was captured. and so the uncertainty persists. Most likely, it's a motion blur artifact from a long exposure. Probably, almost certainly.
But that small possibility that it might be something else, something closer, something that isn't 3I Atlas but was near Mars during the flyby refuses to go away. August 15, 1977, Ohio State University's Big Ear radio telescope detected a 72-second burst of radio energy, so unusual, so perfectly structured, that astronomer Jerry Ehman circled it on the printout and wrote one word in red pen: wow. For nearly 5 decades, that signal has remained one of the greatest mysteries in the search for extraterrestrial intelligence. Picture the moment Ehman is reviewing computer printouts from the previous few days of observations. The Big Ear telescope automatically scans the sky recording radio intensity at different frequencies. Most of the time, it records nothing but background noise, the gentle cosmic hiss of the universe, punctuated occasionally by terrestrial radio interference or distant astronomical sources like pulsars or quasars. The data gets printed in columns showing signal strength. Background noise typically registers as 1s or 2s on a scale where letters represent values above 9. A typical printout looks like this: 1, 1, 2, 1, 1, 1, 2, 1, random low-level noise stretching for pages. But on August 15th, in the middle of otherwise unremarkable data, Ehman sees this sequence, 6EQUJ5. The letters represent signal strength between 10 and 35 times above background. The progression shows the signal rising as the telescope's fixed position swept across the source, reaching maximum intensity, then falling as the source moved out of the beam. It's the exact signature you'd expect from a point source in the sky, a star or something orbiting a star. The signal came from the direction of Sagittarius, near the constellation's densest star fields. It was narrowband focused at one specific frequency around 1420 MHz, the hydrogen line the most abundant element in the universe, and a frequency that many scientists believe would be an obvious choice for interstellar communication. Why hydrogen? Because it's everywhere. Every advanced civilization would know about hydrogen. The universe is 75% hydrogen by mass, and hydrogen atoms emit a characteristic radio frequency when their electrons transition between energy states, 1420.405751 MHz to be precise. It's one of the most distinct spectral lines in radio astronomy. If you wanted to send a signal that any technological civilization would recognize as artificial, not natural cosmic noise, but deliberate transmission, you might choose the hydrogen line. It's like broadcasting on a frequency you know everyone is listening to. The signal was strong. It peaked at 30 times the background noise level. For 72 seconds, the time it took for Earth's rotation to sweep the Big Ear's fixed antenna beam across that point in the sky, we received what appeared to be a deliberate transmission from the stars. And then it vanished. Hundreds of follow-up observations. Thousands of hours of listening time pointed at the same region of sky. Different telescopes, different frequencies, different times of day and year. Nothing. Just that one burst 48 years ago, and then eternal silence. Explanations have been proposed. Maybe it was a satellite passing through the beam, except no known satellites were in that position at that time, and the signal came from a fixed celestial coordinate, not a moving source. Maybe it was terrestrial interference, except the frequency was in a protected radio astronomy band, where transmission is illegal and the signal characteristics don't match terrestrial sources. Maybe it was a passing comet or asteroid reflecting radio waves from Earth, except the signal strength and narrowband nature don't fit that explanation. Or maybe, just maybe, it was exactly what it appeared to be, a transmission from an extraterrestrial intelligence, brief and powerful, never repeated, because its purpose was already accomplished. What purpose? Perhaps a greeting, a beacon, an announcement. Or perhaps a reconnaissance signal checking for signs of technological life before committing to a closer approach. Which brings us to Avi Loeb's calculations.
until Avi Loeb ran the numbers on 3i Atlas. He calculated where the object was on August 12, 1976, just 3 days before the WOW signal was detected. The answer approximately 600 astronomical units from Earth. That's 600 times the distance between Earth and the Sun, roughly 14 times farther than Pluto's average orbital distance.
Out in the darkness beyond Neptune's orbit in the region where the solar system gradually fades into interstellar space. But more importantly, he calculated what direction 3i Atlas was coming from at that time. Right ascension, 19 hours, 40 minutes. Declination positive 19 degrees. The WOW signal came from right ascension, 19 hours, 25 minutes. Declination negative 27 degrees. In celestial coordinates, right ascension is like longitude. It measures position around the celestial equator in hours, minutes, and seconds. Declination is like latitude. It measures position north or south of the celestial equator in degrees. The two directions are separated by approximately 9 degrees. That might sound like a lot until you realize the entire sky spans 360 degrees of right ascension and 180 degrees of declination. The probability that a randomly positioned interstellar object would align within 9 degrees of a randomly positioned radio signal, approximately 0.6%. Not impossible,
but deeply suspicious. Think of it this way: if you threw a dart at a map of the world without looking, and then threw another dart, years later, what are the odds they'd land within a few hundred kilometers of each other? Possible, yes, but unlikely enough to make you wonder whether something other than chance was at play. In the vastness of space, with random objects coming from literally any possible direction across the entire celestial sphere, the probability of this alignment is about 0.6%. Less than 1 in 100. Loeb didn't stop there. He asked the next logical question. If 3i Atlas sent the WOW signal from 600 astronomical units away, how powerful would the transmitter need to be? The math is straightforward, though the implications are not. The detected intensity was between 54 and 212 Janskys across a 10 kHz bandwidth. A Jansky is a unit of spectral flux density, basically a measure of how much radio energy reaches your detector. At 600 AU distance, accounting for the inverse square law of radiation propagation, that corresponds to a transmitter output between 0.5 gigawatt and 2 gigawatts. For reference, a typical nuclear reactor on Earth produces about 1 gigawatt of electrical power. So we're talking about nuclear power plant levels of energy focused into a narrow radio beam transmitted from a point 600 times farther from the Sun than Earth is. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting. Consider Earth has been inadvertently broadcasting radio waves into space since the 1930s, when commercial radio became widespread. Television signals, radar installations, satellite communications, all of it leaking into space. But these signals are weak diffuse, spreading in all directions. By the time they travel even a few light years, they're barely distinguishable from background noise. To intentionally communicate across interstellar distances, you need concentrated power in a narrow beam at frequencies that penetrate interstellar dust and aren't drowned out by natural cosmic noise. You need exactly the kind of signal the WOW detection showed. There's another detail that makes the connection harder to dismiss. The WOW signal was observed at a frequency of 14 to 20.4556 MHz, blue shifted by approximately 10 km per second toward Earth, relative to the hydrogen line. That blue shift indicates the source was moving toward us. 3i Atlas is currently approaching the Sun at about 60 km per second. Loeb suggests that if this object has maneuvering capability, it could have been moving slower in 1977, then accelerated after detecting habitable zone planets in our solar system. A reconnaissance pulse, A radar scan checking for signs of technological civilization before committing to a closer approach. It's speculation. Yes, but it's speculation based on actual data, real calculations, and reasonable assumptions about how an advanced civilization might explore the galaxy. Here's what makes this entire connection so frustrating it would be trivially easy to check. Point a radio telescope at 3II Atlas. Listen at the hydrogen line frequency. If it's transmitting, we'll know within hours. If it's silent, the WOW signal connection is probably coincidental. Simple test, definitive answer. And yet, as Loeb noted in his latest blog post, not a single radio telescope has reported data on 3I Atlas. The Very Large Array hasn't looked. The Arecibo telescope is destroyed. The Green Bank telescope hasn't published observations. Even SETI, the organization literally dedicated to finding extraterrestrial signals, hasn't publicly announced any monitoring efforts. The silence from the radio astronomy community is deafening. Why is it because they consider the hypothesis too unlikely to waste telescope time? Is it because they have looked and found nothing, making the null result uninteresting enough not to publish? Or is it because they've looked and found something and the implications are so profound that they're still figuring out how to present the data we don't know? And that uncertainty compounds every other uncertainty surrounding this object. Imagine throwing a dart at a globe from across a room while blindfolded. Now imagine that dart not only hits the globe, but lands within a few degrees of the equator. That's roughly the statistical improbability we're dealing with when we look at how 3I Atlas entered our solar system. Objects coming from interstellar space can arrive from literally any direction. There's no preferred orientation. The galaxy doesn't have a top or bottom in any meaningful sense. Interstellar objects should be randomly distributed across the celestial sphere, coming in at all possible angles with roughly equal probability. And yet 3I Atlas arrived with an orbital inclination of just 4.9 degrees relative to Earth's ecliptic plane, less than 5 degrees. That puts it in less than 1% of possible arrival angles. Avi Loeb has been hammering this point in every interview, every blog post, every public statement since July. The trajectory is anomalous, not just unusual, statistically profoundly unlikely for a random interstellar object. To understand why, you need to think about how objects move through the galaxy. Stars in the Milky Way disk orbit the galactic center with some average velocity about 220 kilometers per second for stars in our neighborhood. But they also have random motions up and down, side to side, like bees swarming around a hive. These random velocities, called peculiar velocities, typically range from 10 to 40 kilometers per second. That randomness means objects ejected from other star systems, comets, kicked out by gravitational interactions. Planets ejected from their home systems, whatever should arrive at our solar system from all directions with roughly equal probability. There's no preferred direction, no cosmic highway that funnels interstellar visitors into our ecliptic plane. And before someone suggests that maybe objects from the Milky Way disk naturally arrive at shallow angles, Loeb addressed that too. The galactic disk itself is tilted about 60 degrees relative to our solar system's ecliptic plane. 60 degrees. That's more than 10 times larger than the inclination of 3I Atlas. If this object came from a typical star system in the galactic disk and was ejected randomly, we'd expect it to arrive at a steep angle, not a shallow one.
The alignment is backwards from what galactic geometry would predict. Compare 3I Atlas to the only other interstellar objects we've detected. Oumuamua, discovered in 2017, arrived with an inclination of 123 degrees, wildly tilted, coming in from above the solar system plane if we think of the ecliptic as horizontal. It was so tilted that it actually approached from the direction of the constellation Lyra, coming down through the plane of the solar system at a steep angle. Its trajectory was bizarre. In other ways, too, it accelerated slightly as it left the solar system a thrust that couldn't be explained by solar radiation pressure alone given its observed properties. 2I Borisov, spotted in 2019, had an inclination of 44 degrees. Still steep, still consistent with random arrival from interstellar space. Borisov looked and behaved like a normal comet in most respects. It had a distinct coma and tail. It outgassed water and carbon monoxide as expected when heated by the sun.
Spectroscopic analysis showed chemistry consistent with comets from our own solar system. It was weird only in the sense that it came from somewhere else. Its origin beyond our solar system was the remarkable thing about it, not its properties. Both of those objects behaved exactly as expected for natural interstellar visitors. Random approach angles reflecting the random velocities of objects ejected from other star systems. No preference for the ecliptic plane. No mysterious alignment with significant directions or previous astronomical events. 3I Atlas is the outlier, the anomaly. The one that doesn't fit the pattern established by the first two. And in statistics, when you have a small sample size, outliers are particularly significant. They might represent measurement error or rare but natural variation. Or they might represent something genuinely different, something that doesn't belong to the same population as the other data points. Loeb calculated the probability of this alignment assuming random directions less than 1% chance. He used straightforward solid angle calculations. The celestial sphere has a total solid angle of 4p steradians. The ecliptic occupies a narrow band around that sphere. Objects arriving within 5 degrees of the ecliptic plane occupy only about 0.5% of the total possible directions. Some colleagues push back, suggesting maybe his statistics were too conservative. Maybe he didn't properly account for selection effects, the possibility that our detection methods are biased toward finding objects in or near the ecliptic because that's where we concentrate our surveys. Maybe the true probability is closer to 5 or 10% when you account for various observational biases and uncertainties in the trajectory determination. Fair criticism. Statistics can be tricky and observational biases definitely exist. We do tend to find more asteroids and comets near the ecliptic because that's where most surveys focus. The major planet-searching telescopes look along the ecliptic because that's where planets orbit. The asteroid surveys look there because that's where most asteroids are. But interstellar objects aren't confined to any particular region. They can come from literally anywhere. And the surveys that detected 3I Atlas weren't specifically targeting the ecliptic. They're all sky surveys looking for anything transient or moving. The detection shouldn't be significantly biased by ecliptic proximity. Fine. Even if we accept the more conservative probability estimates even at 10%, you're still looking at something that should only happen once in every 10 interstellar objects we detect. And we've only detected 3 total. 3 objects in 8 years of serious searching with modern surveys capable of finding interstellar visitors. The odds of the third one being the rare 10% exception rather than the much more common 90% normal case are well 1 in 10. Possible, but not the way you'd bet if you were being rational about probabilities. Now layer that on top of everything else. The wow signal alignment also less than 1% probability if the direction is random. The chemical anomalies with nickel, but virtually no iron, statistically very unlikely based on what we know about stellar nucleosynthesis and the formation of comets. The thermal contradictions between outgassing rate and infrared temperature. The missing high-resolution images from multiple space agencies simultaneously. The government shutdown happening at the exact moment we need NASA most operational. The social media suppression ramping up precisely when questions intensified. Any single one of these things could be explained away. Coincidence, measurement error, bureaucratic incompetence, algorithmic glitches.
Natural but rare phenomena. But when you start stacking anomalies, when you start multiplying small probabilities together, the compound improbability becomes harder to dismiss with a wave of the hand and an appeal to coincidence. Let's do the math. If the trajectory alignment has a 1% probability, and the WOW signal alignment has a 1% probability, and these are independent events, which they should be if both are coincidental, then the probability of both occurring is 0.01 times 0.01, which equals 0.001, 1 in 10,000. Add in the other anomalies each with their own small probability if we're assuming natural explanations, and you quickly get into 1 in a million territory. Now there's a principle in statistics called the prosecutor's fallacy. It's the mistake of treating multiple independent low probability events as if they're related when they're actually just random coincidences that happen to cluster together.
If you flip a coin enough times, eventually you'll get 10 heads in a row. That sequence has a probability of about 1 in 1,000. Rare, but not impossible. And if you flip coins long enough, you'll definitely see it eventually. The improbability becomes certainty given enough trials. Skeptics will argue that's what we're seeing with 3I Atlas, a natural comet that happens to have several unusual but ultimately explainable properties that coincidentally appeared together in the same object. Unlikely, sure, but we're sampling from a huge population of potential interstellar visitors. Billions of comets get ejected from star systems across the galaxy. Eventually, one of them will be weird in multiple ways simultaneously just by chance. It's like the lottery. The probability that any specific person wins is infinitesimally small, but the probability that someone wins is essentially certain. Someone has to win.
And when they do, we don't assume the lottery was rigged just because it's so unlikely that this particular person won. We accept that improbable outcomes happen to someone eventually. The counter-argument is equally valid, and it's where careful thinkers have to make judgment calls about what hypotheses deserve serious consideration. If something walks like a duck, quacks like a duck, swims, like a duck has duck DNA lives with other ducks and is identified as a duck by multiple independent observers using different methods. At some point, you have to consider the possibility that it might actually be a duck.
Or in this case, if an object arrives on a statistically unlikely trajectory that points back to a decades-old unexplained radio signal, shows chemical signatures that don't match natural cometary processes, exhibits thermal properties, inconsistent with standard physics, correlates with institutional behavior, suggesting something unusual was observed, and prompts coordinated reluctance to share high-resolution data across multiple sovereign space agencies. Maybe, just maybe, it's worth seriously considering that we're not looking at a random chunk of ice and rock from another star system. This is speculation. Let me be absolutely clear about that. The natural explanation remains the most likely by far. Comets are weird. They do unexpected things. Our understanding of interstellar chemistry is limited by a tiny sample size. Institutional behavior is often dysfunctional without any conspiracy being involved. Coincidences happen more often than our intuition suggests. The base rate for natural comet is extraordinarily high. Billions of comets exist in our galaxy. We've detected exactly 0 confirmed technological artifacts from extraterrestrial civilizations. So even if 3I Atlas has multiple anomalies, the prior probability strongly favors a natural explanation simply because natural objects vastly outnumber artificial ones in our observational experience. But the alternative deserves consideration. Not acceptance, not yet, not without much more evidence, but serious, rigorous investigation using all available tools and data without prejudging the outcome based on what we expect or hope to find. Science advances by taking anomalies seriously, by not dismissing them as mere statistical flukes until we've exhausted natural explanations, by maintaining enough open-mindedness to consider hypotheses that seem unlikely but aren't impossible. The history of science is full of cases where the anomaly turned out to be revolutionary. Continental drift was dismissed as impossible until it was proven. Prions, infectious proteins without nucleic acids, were thought to violate basic principles of biology until they were discovered. High-temperature superconductivity was considered theoretically impossible until materials exhibiting it were synthesized. Sometimes the anomaly is just noise. Sometimes it's poor methodology. Sometimes it's wishful thinking, but sometimes rarely, but significantly, the anomaly is real. And pursuing it leads to new understanding, which brings us to the question of why that investigation seems to be so difficult right now, why the institutions we rely on for this kind of inquiry are remaining so remarkably quiet. Something strange started happening around October 5th. Users across multiple platforms began reporting that their posts about 3i Atlas were disappearing, not being flagged or marked as misinformation, actually vanishing. A Reddit user documented posting a detailed thread analyzing the chemical anomalies from the alleged ESA leak. The thread gained traction, accumulated hundreds of upvotes and dozens of comments within 2 hours. Then it was gone, not removed with a moderator explanation, just deleted from existence. When the user tried to repost, the submission wouldn't go through. Shadow banned without notification or explanation. On Twitter, now X, several accounts noticed similar patterns. Astronomy Vibes. The account that went viral criticizing the ESA photos reported significant engagement drops after October 7th. Posts that would normally reach tens of thousands of people were suddenly plateauing at a few hundred views. No official restrictions, no warning messages, just algorithmic suppression. Quiet enough to be deniable, but aggressive enough to be effective. Other creators in the space astronomy community noticed the same thing. Videos about 3i Atlas that would typically perform well were getting a fraction of their usual reach, as if the algorithm had decided this particular topic wasn't worth promoting. YouTube presented a different problem. Content creators who posted analysis videos speculating about 3i Atlas began receiving demonetization notices. The stated reason varied. Some were flagged for discussing sensitive topics without proper context. Others were categorized as potentially misleading content about scientific matters. A few got hit with the vague but ominous label of content that may not be suitable for all advertisers. The pattern was clear. You could make a video saying, 3i Atlas is definitely just a comet and mainstream science has it figured out. That was fine. Monetized, promoted. But suggest there might be anomalies worth investigating. Suddenly, your video becomes advertiser unfriendly. Facebook's approach was the most overt. The platform's fact-checking system, operated by third-party verification organizations, started aggressively labeling 3i Atlas content. Posts sharing the 4chan leak got slapped with missing context warnings. Claims about the trajectory anomalies were flagged as partly false, even when the posts were just quoting Avi Loeb's published calculations verbatim. The fact-check articles offered reassurance. Space agencies confirm no threat from interstellar comet. Experts say unusual features, likely natural processes. The subtext was clear. Don't worry, don't speculate. Trust the authorities. Move along. The timing felt coordinated. All of this ramped up within 48 hours of the ESA photo release, right when public frustration was peaking over the lack of quality images. Now let's be clear about something. Social media platforms suppress content all the time. Algorithms change. Engagement fluctuates. Fact-checkers flag misinformation. These are normal platform operations, not necessarily evidence of coordinated censorship, unless there's a pattern. Unless it's all happening at once, targeting one specific topic right at the moment when public interest is highest and official answers are most absent. Some creators started using coded language to avoid suppression. Instead of 3i Atlas, they'd say the visitor or the object. Instead of alien or extraterrestrial, they'd use non-terrestrial or anomalous. It was like watching people develop a new vocabulary to discuss something the platforms didn't want discussed openly. The Streisand effect in real time. The more the content got suppressed, the more people assumed there was something worth hiding. The more aggressively fact-checkers pushed back, the less people trusted the official narrative. Every attempt to manage the conversation just amplified the suspicion that the conversation needed to be managed. Is this evidence of conspiracy? Of coordinated information control across multiple platforms and governments? Possibly, it's one explanation, but there are others. Platform algorithms are notoriously opaque and sometimes catch legitimate content in overly broad filters. The recent explosion of AI-generated misinformation has made tech companies extremely cautious about allowing speculation on scientific topics to spread unchecked. And the fact that 3i Atlas speculation often bleeds into UFO and conspiracy territory makes it an easy target for automated content moderation. Hanlon's razor suggests we should never attribute to malice what can be adequately explained by incompetence, or, in this case, by algorithmic overreach and institutional overcaution. But whether through coordination or convergent caution, the effect is the same. Questions about 3i Atlas are harder to ask publicly than they should be.
And that difficulty fuels the very speculation that platforms claim to be combating. October 29th and 30th. Mark those dates. In the coming weeks, 3i Atlas will reach perihelion, its closest approach to the Sun. It will pass at a distance of approximately 202 million kilometers, just inside the orbit of Mars. For a natural comet, this is the moment of truth. The intense solar radiation at that distance should cause dramatic outgassing, possibly even fragmentation. We've seen it happen before. Comets get close to the Sun, the heat becomes too much, and they break apart into pieces. It's spectacular when it happens, and it tells us a lot about the comet's internal structure and composition. And if 3i Atlas is just an ordinary chunk of ice and rock from another star system, that's exactly what should occur. But here's the problem. We won't be able to see it. 3i Atlas will be on the opposite side of the Sun from Earth during its perihelion passage. Every ground-based telescope on our planet will be useless.
The object will be lost in the solar glare, completely hidden from observation during what should be its most active and revealing moment. Some are calling it unfortunate timing. Others see it as suspiciously convenient. If you wanted to do something without being watched, you couldn't pick a better window. Avi Loeb has been explicit about what happens next. In his October 3rd blog post, published on the day of the Mars flyby, he laid out two scenarios. Scenario 1. If 3i Atlas is a natural comet, it may erupt in a flare of outgassing or break up into icy fragments soon. The sunlight will deposit gigawatts of power onto its surface. That energy has to go somewhere. For ice and rock, it goes into vaporization, sublimation, possibly structural failure, standard comet behavior, expected, natural. But then Loeb added the alternative. Scenario 2. If it is technological, it may maneuver to benefit from the Sun's gravitational assist or release probes that could intercept the Earth or other planets, owing to its retrograde orbit opposite, in direction to the motion of the planets around the Sun. Read that again. Release probes that could intercept Earth. He's not talking about passive observation anymore. He's talking about active deployment. The retrograde orbit is key here. 3i Atlas is moving opposite to the direction planets orbit the Sun. That means any probe it releases doesn't have to fight against planetary motion to reach us. It can simply drop into an intercept trajectory and let orbital mechanics do the work. From behind the Sun, hidden from our view, it would be trivial to launch something toward Earth that wouldn't be detected until it was already close. Loeb went further. He wrote, "When you look at the Sun in the coming weeks, keep in mind that 3i Atlas is passing behind it. If 3i Atlas will maneuver towards Earth when it reappears on the other side of the Sun, the financial markets may crash." Financial markets may crash. That's not metaphor. That's not hyperbole. He's suggesting that if this object demonstrates technological capability, if it alters course toward Earth after perihelion, the economic and social consequences would be immediate and severe. Stock markets respond to uncertainty. The uncertainty of a potentially hostile interstellar object actively changing its trajectory toward our planet would be existential level uncertainty. Panic selling, market collapse, economic chaos. The timing of everything compounds the tension. The government shutdown means NASA is offline during the critical observation window. The best images from the Mars flyby are still unreleased. Amateur astronomers can't observe the object for the next month because it's behind the sun. Radio telescopes haven't checked for transmissions. We're flying blind into the most important moment of this entire encounter. And whether through incompetence or design, we've created a situation where we won't know what 3i Atlas does at perihelion until it's already done it. There is one group watching. The Galileo project led by Loeb himself operates 3 observatories, one in Massachusetts, one in Pennsylvania, one in Nevada. They're equipped with high-resolution cameras, infrared sensors, and radio receivers designed specifically to detect anomalous aerial phenomena. During late October and early November, all 3 observatories will be in maximum operational mode, monitoring the skies for anything unusual. If 3i Atlas releases probes, if there's enhanced UAP activity correlated with its perihelion passage, the Galileo instruments might catch it. Might being the operative word. 3 observatories covering a small fraction of Earth's sky. If something comes and it avoids those specific observation zones, we'll miss it entirely. And then there's the question of what happens if they do detect something. Will they announce it immediately? Will they gather more data first? Will they coordinate with government agencies before going public? These are not idle questions. The scientific community has long debated the appropriate protocols for announcing the detection of extraterrestrial intelligence. Premature announcements can cause social disruption, but delayed announcements can fuel conspiracy theories and erode public trust. There's no perfect solution. Every choice involves trade-offs. What we know for certain is that in November, 3 Atlas will emerge from behind the sun. We'll be able to observe it again from Earth. And we'll finally have answers to at least some of the questions that have been accumulating since July. Or we'll have new questions. Deeper ones. More troubling ones. The uncertainty is exhausting, but it's also thrilling. We're living through a moment that might be historically significant or might be nothing at all. We won't know which until it's over. Early November. That's when 3i Atlas will emerge from behind the sun and become visible again from Earth. Ground-based telescopes will be able to track it once more. We'll see whether it survived perihelion intact or broke apart under solar stress. We'll measure its trajectory to determine if any course corrections occurred. And we'll finally know whether the past 4 months of speculation, conspiracy theories, and unanswered questions were justified or just collective hysteria over a completely natural interstellar visitor. If 3i Atlas emerges on the same trajectory, it entered with if it shows clear signs of fragmentation or increased outgassing consistent with solar heating. If it behaves exactly like 2i Borisov did during its solar approach in 2019, then the mystery is essentially solved. Natural comet. Unusual chemistry, sure. Statistically unlikely trajectory, granted. But ultimately, just an icy remnant from another star system passing through ours. The WOW signal connection becomes coincidence. The 4chan leak becomes creative fiction. The missing NASA images become bureaucratic delays during a government shutdown. Everything slots back into the comfortable framework where interstellar objects are interesting but not alarming. But if it doesn't, if 3i Atlas emerges with an altered trajectory, if it demonstrates even subtle course corrections that can't be explained by outgassing thrust, if radio telescopes finally point at it and detect structured transmissions, if the NASA images eventually surface and show geometric structures that shouldn't exist on a natural object, then we're in completely uncharted territory. Not just scientifically, socially, politically, economically. Every assumption about our place in the cosmos gets challenged. Every government's response to the question of extraterrestrial contact gets tested in real time. Avi Loeb created something he calls the Loeb scale. It's a ranking system for how likely an object is to be of artificial origin and how much of a potential threat it represents. Rank 1 means almost certainly natural with interesting but explainable anomalies. Rank 10 means definitely artificial with demonstrated hostile intent and capability to reach Earth. He stated publicly that he won't rank 3I Atlas lower than a 2. Even in the best-case scenario, the anomalies are too persistent, too numerous, too correlated. A 2 means probably natural, but with enough unexplained features to warrant serious investigation. It means we can't definitively rule out artificial origin without more data. That's where we are right now, suspended between probable natural object and possible technological artifact, waiting for November. Waiting for the high-resolution images that may never come. Waiting for radio observations that haven't happened. Waiting for 3I Atlas to either continue on its hyperbolic trajectory out of the solar system never to be seen again, or to do something that forces us to confront the reality that we are not alone and we are not ready. The ESA has announced that their Jupiter Icy Moons Explorer spacecraft JUICE will observe 3I Atlas between November 2nd and 25th using various instruments. This will happen just after perihelion, when the object should be in its most active state. The data won't be available until February 2026 due to communication delays and processing time. 7 months of waiting for images that were captured in November. 7 months of not knowing whether the enhanced activity JUICE observes is normal cometary outgassing or something else entirely. 7 months of wondering whether that fuzzy dot the ESA showed us in October was really the best they could do, or whether they're carefully managing a revelation they don't know how to deliver. Whatever 3I Atlas is, whatever it does in the coming weeks, the conversation around it has already revealed something important about where we are as a civilization. We don't trust our institutions to tell us the truth about something this significant. We don't believe the official reassurances. We see patterns in the timing of shutdowns and data delays that may or may not be real. We're primed for conspiracy because we've learned sometimes the hard way that conspiracy is not always theory. Sometimes it's just early reporting on what later becomes confirmed fact. Let's explore what this entire situation reveals about humanity, regardless of what 3I Atlas turns out to be. Because in many ways our reaction to this object is as fascinating as the object itself. We are witnessing not just a cosmic visitor, but a mirror held up to human psychology, our institutions, our capacity for wonder and fear, our relationship with the unknown. If it's natural, we've learned that statistical improbabilities do occur. The universe can surprise us even with ordinary objects. Our pattern recognition instincts evolved for survival on the African savanna sometimes misfire when applied to cosmic phenomena. These instincts served us well for millions of years. The ancestor who saw a pattern in the rustling grass and assumed a predator survived more often than the ancestor who assumed it was just wind. Natural selection favored false positives seeing threats that weren't there over false negatives missing threats that were. We inherited that bias. We see faces in clouds, animals in constellations, conspiracies in coincidences. It's not a flaw, it's a feature. But it's a feature designed for a different environment than the one we're trying to understand now. The savannah had predators. Space has mysteries. Our brains sometimes confuse the two. We've also learned that information vacuums breed speculation. When authoritative sources remain silent or provide inadequate data, people fill the void with their own explanations, some reasonable, some wild, all competing for attention in the marketplace of ideas. This is human nature. We are storytelling creatures. We need narratives to make sense of experience. When official narratives are absent or unsatisfying, unofficial narratives emerge to fill the gap. You can't stop this process. You can only shape it by providing better information, more transparency, clearer communication. The need for better international coordination on space observation becomes clear. When multiple agencies have data but don't share it promptly or comprehensively, trust erodes and conspiracy theories flourish.
The vacuum created by silence gets filled with speculation, and once speculation takes root, it's extraordinarily difficult to uproot even with subsequent evidence. But if 3i Atlas is technological, if it's artificial, everything changes about our cosmic context in ways that ripple through every domain of human thought and culture. We are not alone. That ancient question asked by every human culture since we first looked up at the stars finally has an answer. The question that has driven philosophy, religion, science fiction, space, exploration for generations, are we alone in the universe, receives its answer in the affirmative. Not alone. Never alone. The universe is populated. Consider what that means. Every human who ever lived wondered whether other minds existed beyond Earth. Billions of people across thousands of generations asked that question into the darkness. Shamans and priests and philosophers and scientists, artists and dreamers and skeptics, all asking, is anybody out there? And the answer comes not as a radio message we can decipher, not as a greeting we can understand, but as an object passing through our solar system with properties that don't quite fit natural explanations. We are not the most advanced. That's a humbling realization, perhaps even a troubling one. Other civilizations solved interstellar travel. They achieved technological capabilities we can barely imagine. They're here in our solar system, and we had no idea they were coming until they were already inside. Humanity has grown accustomed to being at the apex. We're the smartest species on our planet. We reshape continents, split atoms, decode genomes, build thinking machines. For all our problems and failures, we're pretty impressive by terrestrial standards. But on a cosmic scale, we might be the primitive ones.
The young species just beginning to understand the universe, observed by civilizations that achieved spaceflight while our ancestors were still hiding from predators in the African savanna. It's a necessary humility. We've been humbled before. We learned Earth isn't the center of the universe. We learned our sun is an ordinary star among hundreds of billions. We learned our galaxy is one among hundreds of billions of galaxies. Each revelation pushed us further from the center, made us smaller in cosmic terms. But each revelation also expanded our understanding, opened new questions, drove new exploration. The loss of cosmic centrality hasn't diminished us. It's liberated us to see clearly what we actually are. One species on one planet at one moment in cosmic time, participating in something vastly larger than ourselves. What does that say about our cosmic neighborhood? If one interstellar visitor can travel here, others can too.
The universe may be far more populated than we assumed. The Fermi paradox. The apparent contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them gets new data points. Enrico Fermi famously asked, "Where is everybody?" Given the age of the universe, the number of stars, the apparent ease with which life arose on Earth, we should see evidence of extraterrestrial intelligence everywhere. The fact that we don't seems paradoxical. Explanations range from pessimistic to optimistic. Maybe intelligent life is extremely rare. Maybe civilizations inevitably destroy themselves before achieving interstellar travel. Maybe interstellar travel is impossible regardless of technological advancement. Maybe aliens exist but have no interest in contacting us or visiting us. Or maybe the answer to "where is everybody" is "they're here. We just didn't recognize them." Maybe interstellar probes pass through our solar system regularly, and 3i Atlas is the first one we had the technology to detect and examine closely. Maybe the universe is filled with traffic we've been oblivious to, like ants unaware of the highway above their nest. The contact question becomes urgent.
How does humanity react to confirmed extraterrestrial technology? Who speaks for Earth? Currently, no one. We have no unified protocol. The United Nations has discussed this scenario but never formalized a response framework. Various academic and scientific organizations have proposed guidelines, but they carry no legal weight and aren't binding on governments. Individual nations might claim authority, but on what basis? Whoever has the most advanced space program gets to be humanity's representative. Whoever detects the signal first. The permanent members of the UN Security Council. The G7. The G20. Each option has problems. Spacefaring nations aren't necessarily representative of humanity's diversity. Nations that detected the signal first might want to monopolize contact for strategic advantage. Major powers often ignore the interests of smaller nations and marginalized populations. And what if the contact isn't with a unified humanity, but with whoever they choose to contact? What if they simply transmit to everyone, simultaneously democratizing contact? Whether we're ready or not, government responses will vary dramatically. Some nations will favor transparency, believing that citizens have a right to know about something this significant. Others will prioritize controlled information, arguing that premature disclosure risks social instability, economic disruption, or panic. Some will see the situation primarily through a national security lens, others through scientific opportunity, others through religious or philosophical frameworks. These different approaches will conflict.
They may conflict publicly and messily, revealing fractures in international cooperation, exposing competing interests and priorities. Religious implications are profound and varied. Does extraterrestrial life challenge theology or enrich it? Some religious traditions accommodate cosmic plurality easily. Islam generally holds that God created life throughout the universe. Buddhism has no theological problem with extraterrestrial beings. The cosmos is vast suffering, is universal consciousness takes many forms. Many indigenous spiritual traditions include beings from the sky or stars in their cosmologies. Others face more difficult reconciliation. Certain interpretations of Christianity emphasize humanity's unique relationship with God, our unique sin and unique redemption through Christ.
How does that framework extend to non-human intelligences? Were they also created in God's image? Did they experience a fall? Do they need salvation? Did Christ incarnate on other worlds too? These aren't trivial questions. For billions of people, religious faith provides meaning, moral guidance, community identity. Challenges to foundational theological assumptions can be existentially destabilizing, but history suggests adaptation is possible. The Catholic Church eventually accepted heliocentrism. Most religious traditions have found ways to integrate evolutionary biology without abandoning core faith commitments. Theology is more flexible than often assumed, capable of incorporating new knowledge while maintaining continuity with tradition. Philosophical questions multiply. What does intelligence mean across cosmic contexts? We define intelligence based on our own example, abstract reasoning, language use, tool, creation, social complexity. But these may be parochial criteria specific to our evolutionary history. Intelligence might manifest in radically different ways under different selection pressures. Maybe intelligence can exist without biology-machine intelligence created by an organic civilization but subsequently operating independently. Maybe intelligence can exist without individual consciousness, a collective hive mind, where intelligence is an emergent property of the group rather than a trait of individuals. Maybe intelligence exists on timescales we can't perceive. We think in seconds, minutes, hours. What if an intelligence thinks in millennia, its thoughts unfolding over epochs? Each decision the result of centuries of consideration. These possibilities challenge our assumptions about mind, consciousness, personhood. They force us to question what we think we know about the relationship between brain and mind biology and intelligence, individual and collective. Economic questions are immediate and potentially destabilizing. How do markets respond to existential paradigm shifts? Stock valuations depend on assumptions about the future, revenue growth, technological development, geopolitical stability, resource availability. Confirmed extraterrestrial technology invalidates many of those assumptions. What happens to defense contractors if human military conflicts become irrelevant in the face of cosmic context? What happens to aerospace companies if extraterrestrial propulsion technology makes our methods obsolete? What happens to energy firms if visitors possess power generation capabilities that dwarf our own? Who benefits? Who loses? Companies positioned to reverse engineer or adapt alien technology might see massive valuation increases. Nations that establish communication might gain strategic advantages. But the transition could be chaotic, wiping out trillions in market value as old assumptions collapse and new realities emerge. Avi Loeb's warning about market crashes isn't hyperbole. It's a realistic assessment of how financial systems respond to uncertainty of this magnitude. And there's the technology gap. If they can cross interstellar space, they're centuries or millennia ahead of us technologically. We're the primitive civilization being studied. It's like ants watching humans' limited comprehension of motives, capabilities, or intentions. Arthur C. Clarke famously wrote that any sufficiently advanced technology is indistinguishable from magic. Their technology might appear to violate the laws of physics as we understand them, not because it actually does, but because we lack the conceptual frameworks to understand what we're seeing. Consider the timing. Why now? Why, during humanity's technological adolescence, we've had radio for roughly 130 years, a cosmic eye blink. We've been detectable as a technological civilization for less than a century. Is there a pattern to when advanced civilizations make contact? Do they wait for certain technological thresholds? Maybe they wait until a species demonstrates certain capabilities, splitting the atom, leaving their planet, detecting interstellar objects, building radio telescopes. These might be milestones that signal readiness for contact, or at least readiness to know contact is possible. Or maybe the timing is random. We happen to exist during a moment when an interstellar probe passed through. Pure chance, no intention, no waiting. Historical parallels offer limited guidance. Contact between civilizations on Earth has often been asymmetric and often traumatic for the less technologically advanced society. But space is different. They don't need our resources. They don't need our land or labor. Post-scarcity civilizations, those that have solved material needs through advanced technology, may have different motivations entirely. Science, curiosity, cosmic catalog building, cosmic communication network establishment. Or they might have motivations we literally cannot comprehend because they emerge from evolutionary pressures and selection forces completely alien to our experience. This is speculation piled on speculation, of course. None of this applies if 3i Atlas is natural. But the exercise of thinking through the implications is valuable regardless. Because even if this specific object turns out to be a comet, the next one might not be. And then the next one after that. Our detection capabilities are improving. We're going to find more interstellar objects. And statistically, if technological civilizations exist and explore the galaxy, eventually we'll encounter evidence of them. Better to think through the implications now while the stakes are still hypothetical than to be caught completely unprepared when they become real. We need to talk about conspiracy theories, not to mock them or dismiss them, but to understand them. Because the conversation around 3i Atlas has become inseparable from conspiratorial thinking, and that has consequences for how we interpret information and evidence. The cover-up theory goes like this: governments know 3i Atlas is artificial and are hiding evidence. The coordinated silence across multiple space agencies suggests shared knowledge. Information is being released strategically to prevent panic following a slow disclosure protocol, to acclimate the public gradually. The government shutdown timing is too convenient to be coincidental. There's internal logic here. If you discovered evidence of extraterrestrial technology, you wouldn't announce it immediately. You'd verify. You'd consult. You'd prepare messaging. You'd coordinate with allied nations. You'd consider national security implications. Silence during that process would be expected, even necessary. The counter-analysis. Coordinating an international cover-up is extraordinarily difficult. Different nations have different interests, different political systems, different levels of transparency. China, Russia, the United States, the European Union, they rarely cooperate smoothly on anything. Leaks would be inevitable. Thousands of people across multiple agencies and nations would need to be read into the secret. Some would talk, some would provide evidence. Whistleblowers emerge even in highly classified programs. And the idea that a U.S. government shutdown was engineered specifically to suppress 3I Atlas data that requires a level of coordination and control that doesn't match how government actually functions. Bureaucratic incompetence explains the timing far more easily than deliberate conspiracy. The manufactured panic theory suggests the opposite. Avi Loeb and others are overhyping a natural object for attention. Media amplifies fear for clicks and engagement. The scientific community is split on whether the anomalies are even real.
Confirmation bias leads people to see what they want to see. Loeb has credentials and reputation at stake. He's a tenured professor at Harvard Chair of the Astronomy Department, published hundreds of peer-reviewed papers. Risking professional credibility on a hoax or exaggeration seems unlikely. But scientists are human. They want recognition. They want their work to matter. And sometimes they overinterpret data or see patterns that aren't there because they want the result to be interesting. The fact that the scientific community is debating these anomalies is healthy. Skepticism is how science corrects itself. Extraordinary claims require extraordinary evidence, the Sagan standard. If Loeb's claims withstand scrutiny, they'll be accepted. If they don't, they'll be rejected. That's how the process is supposed to work. The disinformation campaign theory focuses on social media suppression, creators' documented posts, disappearing engagement, dropping content, being demonetized.
That's not speculation, it happened. But is it coordinated, or algorithmic platforms suppress potentially misleading content routinely? Fact-checkers sometimes get things wrong, flagging legitimate scientific debate as misinformation. Does ham-fisted moderation equal conspiracy? Maybe. Or maybe it's just tech companies overcorrecting in response to criticism about spreading misinformation during elections and the pandemic. So why do humans gravitate toward conspiracy theories? Pattern recognition overdrive. Now, we evolved to see patterns because missing a pattern, mistaking a predator for a shadow, could be fatal. False positives are less costly than false negatives. So our brains err on the side of seeing patterns even when they're not there. Need for narrative coherence. Random events are psychologically uncomfortable. We want stories that make sense, that have causes and purposes. Conspiracies provide narrative coherence. They turn random chaos into deliberate action. Distrust of authority, sometimes earned. Governments and institutions have lied before. MKUltra, the CIA's mind control experiments, was dismissed as paranoid conspiracy until documents proved it was real. NSA mass surveillance was tinfoil hat paranoia until Edward Snowden's revelations confirmed it. Tobacco industry executives testified under oath that cigarettes weren't addictive. Pharmaceutical companies downplayed opioid addiction risks. Corporate and government malfeasance happens. So when institutions say, "Trust us, everything's fine," why should we believe them uncritically? The answer is, we shouldn't. Healthy skepticism is rational, but there's a difference between skepticism and cynicism, between demanding evidence and rejecting all evidence that contradicts your preferred narrative. The balance is difficult, maintaining critical thinking without cynical nihilism.
distinguishing between healthy skepticism and unfounded paranoia, demanding transparency while acknowledging that some information legitimately needs to be withheld for security or ethical reasons. The scientific method offers an antidote: testable predictions, falsifiability, peer review, replication, transparency about methods and data, admitting uncertainty when it exists. Not perfect. Scientists make mistakes. Studies fail to replicate, but over time the process corrects itself through collective scrutiny and iterative refinement. Conspiracy theories resist this process. Contradictory evidence gets incorporated into the conspiracy. Skeptics become part of the plot. Unfalsifiable claims, claims that can't possibly be proven wrong, proliferate. That's not to say all conspiracy theories are false. Some turn out to be true. But truth claims need to be evaluated based on evidence, not based on how satisfying the narrative feels. With 3i Atlas, we're in limbo. Some anomalies are documented. Some are alleged. Some are speculative. We need more data, we need transparency, we need patience, and we need to be comfortable with "I don't know" as an answer while we wait for that data to emerge. Let's ask the uncomfortable question: is humanity prepared for contact? Not just technologically, not just scientifically, but psychologically, socially, institutionally. Are we ready to learn? We're not alone. Institutional preparedness is limited. The United Nations has no functional protocol for extraterrestrial contact, CT. The search for extraterrestrial intelligence has post-detection protocols, but they're not binding. They're recommendations, guidelines that participating scientists have agreed to follow voluntarily. Those protocols suggest verify the signal before announcing, consult with colleagues internationally, inform relevant authorities, make the data publicly available for independent verification. Avoid interpreting the signal beyond what the data supports. Good guidelines.
But what happens when the detection isn't a radio signal but a physical object? What happens when multiple nations have data but different interpretations? What happens when national security concerns clash with scientific transparency? There's no agreement on who speaks for humanity, no single institution with the authority and legitimacy to represent Earth in cosmic affairs. National governments claim sovereignty over their territory, but space belongs to no one. Or everyone, depending on your interpretation of international law. Military response versus scientific response versus diplomatic response, these can easily come into conflict. The military sees threats and defensive postures. Scientists see opportunities for discovery. Diplomats see negotiation and relationship building. Which framework takes priority? Cultural fragmentation complicates everything. Different religions have different interpretations of what extraterrestrial life means. Some theological traditions accommodate cosmic plurality easily. Others face significant challenges reconciling scripture with non-human intelligence. Indigenous perspectives often show more openness to cosmic plurality than Western frameworks. Many indigenous cultures have origin stories involving beings from the sky or stars. They might integrate news of extraterrestrial contact more easily than cultures whose worldviews place humanity at the center of creation. But in practice, Western scientific materialism often dominates global discourse. That's partly due to historical power dynamics, partly due to the dominance of English in international communication, partly due to which institutions control major scientific infrastructure. There's a risk of one culture's framework dominating the global response, marginalizing other ways of understanding and interpreting contact. Economic disruption is probable. Markets hate uncertainty. Confirmed extraterrestrial technology could crash stocks exactly as Avi Loeb suggested, or it could trigger an investment boom in space technology, aerospace materials, science, energy. Whoever reverse engineers or communicates with the visitors might gain strategic advantages. Geopolitical competition for alien knowledge could intensify rivalries and create conflicts.
Psychological impact varies. Some studies suggest people are more resilient than often assumed. Science fiction has normalized the idea of extraterrestrial life. Most people wouldn't panic immediately upon learning aliens exist. But media amplification creates problems. Sensational headlines, conflicting reports, rumor and speculation filling information gaps, social media accelerating both information and misinformation. The overview effect is well documented among astronauts. Seeing Earth from space creates a cognitive shift, a sense of unity, of fragility, of interconnection. National borders vanish.
Tribal conflicts seem petty against the backdrop of cosmic vastness. Contact could trigger a similar shift, a contact effect where knowing we're not alone creates psychological unity, a sense of humanity as a single species rather than competing factions. Or it could trigger existential dread, religious crises, social instability, the collapse of meaning structures that depend on human uniqueness or cosmic centrality. The optimist case. Humanity rises to the occasion. Contact becomes a unifying force. Petty tribalism fades when faced with cosmic context. Scientific cooperation accelerates. A new era of meaning and purpose emerges as we grapple with our place in a populated universe. The pessimist case, panic, instability, conflict. Competing nations vie for extraterrestrial favor or technology. Religious extremism reacts violently to perceived threats to doctrine. Economic collapse and social breakdown as existing institutions prove inadequate. Asymmetric power dynamics, those with access to information versus those without, create new forms of inequality. The realist case. Mixed response. Some areas cope well, others struggle. Gradual adjustment rather than instant transformation. Life continues. People still need food, shelter, meaning, connection, historical parallel. The Copernican revolution, learning Earth orbits the Sun rather than being the center of the universe, took generations to fully integrate into human consciousness. Humans adapt. We're resilient, creative, stubborn. We survived ice ages, plagues, world wars, nuclear standoffs. We'll survive learning about aliens too, but surviving isn't the same as thriving, and the transition could be rocky. What we need: better scientific communication infrastructure that can rapidly disseminate accurate information during crises. International cooperation frameworks that bring diverse voices into decision-making.
Honest public education about possibilities, not fear-mongering, but not sugarcoating either. Cultural humility. No single worldview has a monopoly on truth or the right interpretation. Psychological support systems for people whose meaning structures collapse under the weight of new cosmic realities. Transparent information sharing within reasonable security constraints. History teaches us that major paradigm shifts take time. Knowledge dissemination follows uneven patterns. Elites often gatekeep information, sometimes protectively, sometimes exploitatively. Eventually, truth emerges one way or another. Trying to control information flow often backfires, generating more conspiracy theories than it prevents. The question isn't whether humanity can handle contact. We can. The question is whether we'll handle it well or poorly, wisely or foolishly, together or divided. And that question won't be answered in the abstract.
It'll be answered in the moment, when the news breaks, when the data becomes undeniable, when we have to confront the reality that the universe is vastly more complex than we imagined. If that moment comes. With 3i Atlas or some future visitor, let's take stock of what we actually know versus what remains speculation. What we know for certain, 3i Atlas, is the third confirmed interstellar object detected passing through our solar system. It made its closest approach to Mars on October 3, 2025. 7 spacecraft from 4 space agencies, ESA, NASA, China, UAE, were positioned to observe during the flyby. The European Space Agency released low-resolution images from the ExoMars Trace Gas Orbiter showing minimal detail, essentially a fuzzy dot. NASA's higher resolution high-rise images have not been released. The ongoing U.S. government shutdown affects NASA operations and communication timelines. The object's trajectory shows an orbital inclination of 489 degrees relative to Earth's ecliptic, statistically unusual for an interstellar visitor. Avi Loeb, a respected Harvard astrophysicist, has highlighted multiple anomalies deserving investigation. Amateur astronomers have captured images, some showing apparent structures that might be processing artifacts or might be real features. The data is inconclusive. Social media platforms have suppressed or demonetized some content discussing 3i Atlas, though whether through algorithm or coordination is unclear. 3i Atlas will pass behind the Sun at perihelion in late October, rendering it unobservable from Earth during its closest solar approach. It should emerge visible again from Earth in early November 2025. What remains speculation. Whether chemical composition anomalies, particularly the alleged nickel emission without corresponding iron, are real measurements or errors. Whether thermal contradictions are genuine or explained by normal cometary processes, we don't fully understand. Whether the trajectory alignment with the 1977 WOW signal direction is meaningful or coincidental. Whether the 4chan leak contains any legitimate insider information or is entirely fabricated. Whether social media suppression is coordinated or the result of algorithmic coincidence and overcautious moderation. Whether missing high-resolution images show anything unusual or are simply delayed by bureaucratic dysfunction. Whether 3i Atlas is a natural comet, an unusual natural object of a type we haven't encountered before, or a technological artifact. What we don't know. What 3i Atlas will do at perihelion. Whether it will fragment, increase outgassing, remain stable, or demonstrate something unexpected. Whether its trajectory will change in ways inconsistent with natural forces. Whether radio transmissions exist and whether anyone is actually listening for them. When or if full imaging data from the Mars flyby will be released to the public. What November observations will reveal when the object becomes visible again from Earth. The honest assessment, most likely scenario 3i Atlas, is a natural comet with some unusual but ultimately explainable properties. Comets are weird. They surprise us. Our understanding of interstellar chemistry is limited by a tiny sample size. Possible scenario, it's a natural object of a type we haven't encountered before, requiring new models or explanations, but still within the realm of natural phenomena. Unlikely but not impossible scenario, it's a technological artifact. Either a probe deliberately sent to our solar system, or perhaps some kind of automated beacon or relay station. The uncertainty is uncomfortable, but it's also appropriate given the available evidence. Premature certainty committing to an explanation before the data supports it would be intellectually dishonest. Why questions persist? Information gaps breed speculation. When authoritative sources don't provide clear answers, people fill the void with their own. Statistical anomalies demand explanation. They can't simply be ignored or hand-waved away. Institutional opacity erodes trust. When agencies withhold data without clear justification, suspicion grows. Human curiosity refuses easy dismissals. We want to understand. We want answers. And when those answers don't come, we generate our own, sometimes jumping to conclusions, sometimes asking legitimate questions that deserve better responses than we're getting. The possibility of technological origin, however remote, is too significant to ignore. Even a 1% chance of confirmed extraterrestrial technology would be the most important discovery in human history. That's worth investigating rigorously, even if we expect the answer to be mundane. The value of the mysteries drive progress. The uncertainty around 3i Atlas is pushing for better observation technology, encouraging international scientific cooperation, reminding us how much we don't know about the universe. It keeps us humble about our cosmic understanding. It inspires the next generation of scientists and engineers who will build better telescopes, design better spacecraft, ask better questions. Even if 3i Atlas turns out to be completely natural, this entire experience has value. It's a stress test of our institutions, our communication systems, our ability to handle cosmic uncertainty. It's a rehearsal for the day when we do encounter something genuinely anomalous. Better to learn those lessons now with the stakes still hypothetical than to fumble through them when the stakes are existential. In weeks, we'll have answers. Or more questions, perhaps both. 3i Atlas will emerge from behind the sun in early November. Telescopes worldwide will track its trajectory with renewed intensity.
We'll see if it behaved as natural comets do, fragmenting under thermal stress, increasing its outgassing rate, following predictable orbital mechanics governed by gravity and the subtle push of escaping gases. Or if it did something unprecedented, something that demands new explanations, new physics, new ways of thinking about what's possible in our cosmic neighborhood. The waiting is difficult. Humans are impatient creatures. We want answers now, resolutions, immediately, certainty without delay. But the universe operates on its own time frame, indifferent to our need for closure. 3i Atlas will emerge when orbital mechanics determine it emerges not a moment sooner because we're curious or anxious or desperate to know. In the meantime, we watch the space behind the sun. We monitor our instruments. We prepare our telescopes for the moment when that small point of light becomes visible again against the background stars. And we wonder. This object is one visitor among potentially millions that pass through the galaxy undetected. Our detection capability is improving exponentially with each passing year. Better telescopes with wider fields of view. Better algorithms that can spot faint, fast-moving objects against complex backgrounds. Better international coordination despite current challenges and political tensions. The Vera C. Rubin Observatory, currently under construction in Chile, will be able to image the entire visible sky every few nights once it becomes operational. It will detect objects far fainter than current surveys can find. Interstellar visitors that would have passed unseen a decade ago will be routinely cataloged and tracked. We'll find more interstellar objects in coming years. Dozens, perhaps hundreds.
Each one teaches us about the cosmos beyond our solar system, about planetary formation around other stars, about the chemistry of different stellar environments, about the diversity of cosmic processes we've only begun to catalog. Each one carries the possibility of extraordinary discovery. Most will be natural chunks of ice and rock ejected from other star systems by gravitational interactions. But statistically, if technological civilizations exist and explore the galaxy through probes or automated systems, eventually we'll encounter evidence of them. Maybe 3i Atlas is that evidence. Maybe it's the next one. Maybe we'll wait another decade, another century, another millennium before the pattern becomes undeniable. But we'll keep looking. That's what we do. We are the species that looks up and asks, why? That impulse, that curiosity that drives us to question, to explore, to seek understanding beyond the immediate and practical, is perhaps our defining characteristic. Other species use tools. Other species have complex social structures. Other species communicate. But the drive to understand for its own sake, to know simply because not knowing, is intolerable. That might be uniquely human, or uniquely characteristic of whatever category of intelligence we belong to. We build telescopes and spacecraft to satisfy that question. We build particle accelerators to probe the nature of matter. We sequence genomes to understand the code of life. We create art and music and philosophy to explore meaning and beauty and truth. We argue, speculate, investigate, refine our understanding through collective effort spanning generations. The process is messy but productive. Disagreements lead to better questions. Mistakes teach lessons. Dead ends force creative thinking. The path from ignorance to understanding is never straight, never simple, never as fast as we'd like, but it leads somewhere. Always forward, however slowly, toward greater comprehension of the universe we inhabit. Questions drive progress more than answers ever could. Because answers close doors, they settle matters sometimes prematurely. They create the illusion of completion, the sense that we've reached the end of inquiry. Questions open doors. They lead to new investigations, new technologies, new ways of thinking. They keep us humble by reminding us how much we don't know. They keep us curious by promising that understanding is possible if we're patient and persistent and rigorous enough. Not everything needs immediate resolution. Some mysteries take years or decades to unravel. The nature of dark matter has puzzled physicists for nearly a century. The origin of life remains unknown despite brilliant minds working on it for generations. The wow signal has persisted for 48 years without definitive explanation. That's okay. The uncertainty doesn't diminish the value of the search. In many ways, it enhances it. The questions that take longest to answer are often the deepest, the most revealing about the nature of reality and our relationship to it. Some questions might never be answered. And that's okay too. Comfort with uncertainty is a sophisticated intellectual position more mature than the desperate grasping for certainty that characterizes so much public discourse. Demanding premature certainty often leads to error, accepting false answers just to resolve the discomfort of not knowing. Science is comfortable with "we don't know yet" as a complete sentence. It's honest. It's humble. It acknowledges the limits of current understanding while leaving space for future discovery. It doesn't mistake ignorance for impossibility or uncertainty for meaninglessness. 3 simple words that contain within them the promise of eventual understanding. We don't know yet. Not we'll never know. Not it's impossible to know. Yet, implying future knowledge, continued effort, eventual resolution. Stay curious about what we don't understand. That curiosity is precious. Guard it against the forces that would kill it: premature certainty, cynical nihilism, comfortable ignorance. Question authority, but also question your own assumptions. Demand evidence, but remain open to evidence that challenges your beliefs. Maintain healthy skepticism without cynicism. Skepticism says, "Show me the evidence." Cynicism says, "No evidence will convince me." One is the foundation of rationality. The other is the death of learning. Support scientific investigation with better funding and cooperation. Space exploration operates on shoestring budgets relative to its importance. The entire NASA budget is less than Americans spend annually on pet food. Radio astronomy facilities close due to lack of funding. International collaboration gets disrupted by geopolitical tensions and nationalist rhetoric. These are solvable problems if we prioritize solutions. If we recognize that understanding our place in the cosmos has value beyond immediate practical returns. If we acknowledge that some questions deserve pursuit even when the payoff is uncertain and distant. Demand transparency from institutions while understanding their constraints. Scientists want to share data. That's their instinct. Their training, their commitment to the collective enterprise of human understanding. Bureaucracies slow them down with legitimate concerns about verification, peer review, appropriate framing. Legitimate security concerns sometimes require temporary withholding of information, details about satellite capabilities, encryption methods, vulnerabilities in critical infrastructure. But prolonged secrecy without justification erodes the trust necessary for functioning institutions. The balance is difficult but necessary. Transparency as the default. Secrecy as the exception requiring clear explanation. Keep looking up. We've barely begun to explore. Our solar system remains mostly unvisited. 8 planets, hundreds of moons, millions of asteroids, billions of comets. We've sent robots to a handful of worlds. Humans have walked on one other celestial body besides Earth. We've barely scratched the surface. Interstellar space is vast beyond human comprehension. The nearest star system, Alpha Centauri, is 4.37 light-years away. At the speed of our fastest spacecraft, it would take over 70,000 years to reach it. And that's the nearest one. Most stars are incomprehensibly farther. The galaxy spans 100,000 light-years across. The observable universe extends 93 billion light-years in all directions. We've been looking for less than a century using tools that would seem primitive to civilizations even slightly more advanced than us. We've visited a handful of worlds in our immediate neighborhood. We've detected 3 interstellar objects in the past 8 years, the first 3 ever confirmed. We're just getting started. Rank beginners at cosmic exploration. Children taking their first tentative steps into a universe vastly older and larger and stranger than we currently imagine. Teach the next generation to ask good questions. Not just, what is that, but how do we know, and what would it take to find out? Critical thinking. Evidence evaluation. Comfort with uncertainty. Intellectual humility balanced with passionate curiosity. These are skills that serve well beyond astronomy. They're how we navigate a complex world filled with competing claims, partial information, and deliberate misinformation. They're how we distinguish between what's true and what we wish were true. They're how we make progress toward understanding in any domain. The open-ended question remains, the one we can't answer yet. The one that will linger long after you finish listening to this, echoing in quiet moments when you look up at the night sky and wonder if 3I Atlas emerges in November and simply continues outward, a comet after all unusual but natural. Will we be disappointed that the universe isn't more mysterious than we thought? Will we feel relief that our assumptions remain intact, that the comfortable framework of natural explanations still holds? Or will we feel a twinge of regret that this particular mystery resolved into something mundane, that we weren't living through the most important moment in human history after all? And if it does something impossible, something that forces us to accept we're not alone, that forces us to acknowledge that intelligence exists beyond Earth and has achieved capabilities we can barely imagine. Will that moment mark humanity's graduation into a larger cosmic community? Will we rise to the occasion, setting aside our petty differences to engage thoughtfully and collaboratively with whatever comes next? Will we find the wisdom to navigate this transition with grace and maturity? Or will it reveal how unprepared we are for a universe more complex and populated than our philosophies and institutions can yet accommodate? Will we fracture under the weight of paradigm shift? Will our institutions prove inadequate? Our certainties prove false? Our understanding prove insufficient? The universe holds the answer, and soon, very soon, we'll know which future we're living in. Thank you for spending these 2 hours exploring this cosmic mystery with me, for letting these questions sit in your mind, for following the threads of evidence and speculation, for maintaining that delicate balance between skepticism and wonder that represents the best of human inquiry. Whether 3I Atlas is a wandering iceberg from another star system, an icy remnant of planetary formation around a sun we'll never see, or something our current frameworks can barely conceptualize, its passage reminds us that the universe is vast, strange, and full of surprises we're only beginning to encounter. Whatever answers November brings, the questions we've asked along the way have value independent of their resolution. They push us toward better understanding of not just this object, but of our methods, our assumptions, our capacity for both rigor and imagination. The act of questioning itself is valuable. It exercises our curiosity. It tests our reasoning. It reveals where our knowledge ends and our speculation begins. It forces us to confront the limits of certainty and the necessity of humility when facing the unknown. We've walked through the evidence, the disappointing images that sparked public frustration, the missing high-resolution photographs that should exist but remain unseen. The amateur observations that captured something, whether artifact or artifact processing artifact, we still can't say with certainty. The statistical improbability of the trajectory, the 48-year-old radio signal that aligns with uncomfortable precision, the social media suppression that began exactly when questions became most insistent. We've explored the hypotheses natural comet with unusual but explainable properties, exotic natural object of a type we haven't encountered before, technological artifact from a civilization with capabilities we can barely imagine. We've examined what each possibility means, not just scientifically, but philosophically, culturally, psychologically, how we'd respond, what we'd learn, how humanity might change or stay the same. And we've acknowledged throughout that uncertainty is not failure, that "I don't know" is sometimes the most honest answer available, that rushing to conclusions serves no one but those uncomfortable with ambiguity. The universe continues its ancient dance, indifferent to our need for understanding. Stars form and die, galaxies collide, comets plunge sunward, moons coalesce from dusty disks. Life, at least on one small blue world that we know of, has learned to look outward and ask questions, to build tools that extend our senses and our understanding, to dream of futures where the boundaries of the possible expand beyond recognition. And somewhere in that vastness, my Atlas continues its journey. Behind the sun right now, hidden from our view, doing whatever it does unobserved during these crucial days of perihelion passage. In weeks, it emerges. We point our telescopes. We measure and observe and analyze, and we learn something, even if what we learn is just that comets from other star systems can be weird, that statistical improbabilities sometimes cluster, that our pattern-seeking minds can construct mysteries from mundane phenomena when we want badly enough to believe. Or we learn something else. Something that changes everything, something that future historians will point to as the moment when humanity's cosmic loneliness ended, when we learned we're part of a larger community of minds scattered across the galaxy, when our place in the universe was revealed to be simultaneously smaller and more significant than we imagined. Either way, we learn. Either way, we continue. Either way, we ask the next question, and then the next, driven by the same curiosity that brought us from caves to cities, from stone tools to spacecraft, from wondering about lights in the sky to actually visiting other worlds. The journey continues. The questions multiply. The mysteries deepen even as some resolve. And that's okay. That's how it should be. An answered universe would be a dead universe with nothing left to discover, nothing left to wonder about. We should be grateful that mysteries remain, that the cosmos refuses to give up all its secrets at once, that there's always something more to learn. Keep looking up. Keep asking questions. Keep pushing at the boundaries of understanding, not because you'll get all the answers you won't. None of us will, but because the asking itself has value. Because curiosity is what makes us human, because wonder is its own reward. If you found this exploration thought-provoking, share it with others who wonder about our place in the cosmos, who look up at the stars and feel that same tug of curiosity, that same need to understand. Subscribe to stay updated as this story continues to unfold in real time, as new data emerges as November approaches and then arrives with whatever revelations or disappointments it brings. And tell me, where are you listening from? What time is it there? As you contemplate these cosmic questions, what do you think 3i Atlas really is, natural wanderer or technological visitor? And do you believe we're getting the whole story from our institutions? Or is there more they're not telling us? These aren't rhetorical questions. They're invitations to continue the conversation, to share your thoughts and theories, to add your voice to the collective human attempt to make sense of this extraordinary moment we're living through. Until next time, wherever you are in the world, whatever time it is, sleep well knowing that the universe is far stranger and more wonderful than any of us fully grasp. And if you look up at the stars tonight, before you close your eyes, take a moment to really see them. not as distant points of light, but as suns, perhaps orbited by worlds, perhaps home to minds looking back at us across the cosmic darkness, perhaps wondering as we wonder whether they're alone. Somewhere beyond those stars, something traveled across unimaginable distances to visit our corner of the galaxy. Whether by chance or intention, it's here. And soon we'll know a little more about what that means. Perhaps watching us as we watch it. The universe waits, patient as always, vast beyond comprehension, strange beyond imagination, beautiful beyond words. Sweet dreams.